We're going to look at the last part of uh, 2.3. Okay, there is no test over chapter 2 or anything. It's just strictly based on homework. And in the last module in chapter 2, we're going to talk about inverse functions. So just to show where I'm pulling these documents from, in the lecture notes section, and even though we're in like module 2.3, as far as these lecture notes are concerned, in chapter 9, under section 9.4, there is another PowerPoint called inverse functions. Okay, and I'm going to use this. Okay, so we're going to talk about inverse functions. I'm using this particular chart. I'm also going into the formula sheet section, and I'm going to pull up a unit circle and also the unit circle function values chart. Okay, so I'll be using these three documents. And we'll also be using a calculator, so I'm going to bring that up. All right, so as we begin, I'm going back to this inverse trigonometric functions. And we talked about as far as the calculator is concerned, right, the sine, cosine, and the tangent function. These functions are used to find side lengths, right, and their reciprocals, such as cosecant, secant, and cotangent. Above these keys, we see the inverse of sine, inverse of cosine, and the inverse of tangent. These functions are used to find angle measures. In this particular chart on inverse trig functions, notice we have all 6 inverse functions. Now, as far as the calculator is concerned, you only see arc sine, arc cosine, and arc tangent. But the reciprocal of arc sine is going to be arc cosecant. The reciprocal of arc cosine is arc secant. The reciprocal of inverse of cotangent is inverse of tangent. Okay, so just as in the 6 trig functions, the 6 inverse functions, we have 3 main functions and then 3 reciprocal functions. Also in this particular chart, what we're interested in is the interval in which these angle measures lie. Okay, so notice we talked about the inverse functions are used to find angle measures. For example, the inverse of sine, sometimes called the arc sine, that angle lies in the interval from negative pi over 2 to pi over 2. Right? And it says that the inverse of sine is in quadrants 1 and 4. I'm going to bring up the unit circle, and I actually need to write on this. So I'm just going to pop this in really quick. Okay, so this is just as a visual. The arc sine is going to be located from pi over 2 to negative pi over 2. As you can see from the unit circle, All of the values on the unit circle are positive, right? We don't actually have any negative values. However, we can produce a negative value by rotating the terminal side of our angle clockwise. So that kind of means the following. The arc sine is located on the right-hand side of your unit circle. So notice we do have positive angles. We have 0, well 0 is neither negative nor positive, but we have pi over 6, pi over 4, pi over 3, and we have pi over 2, which is 90 degrees. If I rotate my terminal side counterclockwise, or excuse me, clockwise to produce negative angles, notice that negative, well, 330 degrees, which is 11 pi over 6, we're actually going to write that out as negative pi over 6, because that's negative 30 degrees, right? So if I rotate my terminal side 30 degrees, I get negative 30 degrees, or negative pi over 6. 7 pi over 4 becomes negative pi over 4. 5 pi over 3 becomes negative pi over 3. And then 270 degrees, that becomes negative pi over 2. Okay. So that means if my angles lie in the fourth quadrant, I can't use the positive angle measures. I must use the negative angle measures. Simply based on the fact that for the arc sine, those angles are in the interval from negative pi over 2 to pi over 2, right? 1 and 4. The arc cosine, those angles lie in the interval from 0 to pi. So those angles can lie in quadrant 1 and in quadrant 2. So that means that the arc cosine, it lies in the top half of the unit circle, right? Any one of these angles from 0 to pi. The arc tangent, it lies in the interval from negative pi over 2 to pi over 2, right? So the arc sine and the arc tangent, they both lie along the right-hand side. All right, now we do have the reciprocals, which are not actually used in the course. The arc cotangent, it lies in the interval from 0 to pi. The arc secant lies in the interval from 0 to pi. And the arc cosecant lies in the interval from negative pi over 2 to pi over 2. All right, so let's see how we actually use this chart to determine angle measures. So notice whenever you're asked to find or evaluate an inverse trig function, the answer is an angle measure. All right, so in OneNote, I just actually pulled some problems from the homework set. All right, and this one is similar to question number 1. So it says evaluate the expression, answer in radians without rounding. So we want the arc sine of negative square root of 2 over 2. All right, so the answer, or what we're actually looking for, is an angle measure. So I'm going to interpret this using these intervals. So I'm going to interpret this as what angle, right, because the arc sine is an angle, in the interval negative pi over 2 to pi, positive pi over 2, has a sine value. So notice that even though this is an arc sine, this is no less still a sine value. So it's what angle in the interval from negative pi over 2 to pi over 2 has a sine So when we talk about x, y, and r, sine represents the y value. So just to show where I'm pulling this from, right? So in this unit circle, r is 1. The sine of any angle is y over r. Okay, so I'm going to go back for just a second to the lecture notes. So I believe this was the only set of formulas that are not actually on that formula sheet. So it says that the sine of any angle is the y value over the radius. So notice if I'm in the unit circle, I can take the y value and I can put that over r, right? So in the unit circle, the sine value simply takes on that y coordinate. So we're going to interpret this as what angle in the interval from negative pi over 2 to positive pi over 2 has a sine, which is a y value of negative square root of 2 over 2. So I'm going to look in the unit circle, and I'm going to pull both of these things up together, hopefully. All right, so what angle in the interval from negative pi over 2 to pi over 2, so notice we're concentrating on the right-hand side, has a sine or a y value of negative square root of 2 over 2. So if I look at this angle, right, 7 pi over 4, but notice that our angle has to be in between negative pi over 2 and positive pi over 2. So I'm not going to use the 7 pi over 4 because that's actually outside of our range. I'm going to use a negative angle, which is negative pi over 4. So for my particular problem, it says what angle in the interval from negative pi over 2 to pi over 2 has a sine, which is a y value of negative square root of 2 over 2, and that should be negative pi over 3. All right, so my angle measure is negative pi over 3. Now here's why it's important to use either negative pi over 2 or positive pi over 2. If I were to decimalize these things, right, negative pi over 2, that's going to give me negative 1.57. Positive pi over 2 is going to give me a positive 1.57, right? If I were to use, let's say, negative 7 pi, excuse me, this should have been negative pi over 4. So if I go back to the unit circle for just a second, right? So notice that negative pi over 2 is negative 1.57. If I were to use 7 pi over 4, that's going to exceed my range. All right. So whenever you're dealing with the arc sine and the arc tangent, in order to stay within the proper interval, you must use the negative angle measures. All right. So for my problem number 1, I will have negative pi over 4. All right, let's take a look at another example. It says evaluate the expression, the arc cosine of square root of 2 over 2. So we're going to interpret this as what angle in the interval from 0 to pi, right? Because notice for the arc cosine, our interval changes from 0 to pi. Has a cosine, okay, and remember cosine is the x value of square root of 2 over 2. So I'm going to look in the unit circle, and I'm going to find the angle that has an x value of square root of 2 over 2. So where's my unit circle? Okay. All right, so here's my unit circle. I'm going to look at all of my x values, and I'm looking for the angle that has an x value of square root of 2 over 2. And it looks like it should be the positive pi over 4 angle. So the angle in the interval from 0 to pi that has a cosine or x value of square root of 2 over 2 should be pi over 4. All right, and for the next one, I'm just trying to go through all three. Now, we don't see arc cosecant. Well, we do see them, but not in this form. All right, we actually put those on the calculator. So this one says evaluate the expression, answer in radians, the arc tangent of negative square root of 3. So we're going to interpret this as what angle in the interval from negative pi over 2 to pi over 2 has a tangent, and a tangent is a y over x value, right, of negative square root of 3. All right, so what angle in the interval from negative pi over 2 to pi over 2 has a tangent, which is a y over x value of negative square root of 3? So now here is what I did. I used a combination of the unit circle function value sheet, and I used the unit circle. And I modified my unit circle just a little bit. So I'm going to show you what I mean by that. So let me bring both of these down. And this might make life a little bit easier. All right, now as far as this unit circle is concerned, they only give me x and y. So what I'm going to do is I'm going to go into this side from negative pi over 2 to pi over 2 because this is where the arctangent runs. And I'm just going to jot in the tangent value. Right? So here's what I mean. If I look at pi over 3, right, which is 60 degrees, the tangent for 60 degrees is square root of 3. So I'm going to jot that. I'm going to jot that on my unit circle. The tangent of 45 degrees, which is pi over 4, that gives me 1. So I'm just going to jot that in as a 1. The tangent of pi over 6, which is 30 degrees, that gives me square root of 3 over 3. And then I'm going to do the same thing down here. So for 11 pi over 6, which is 330 degrees, the tangent should be negative square root of 3 over 3. So I'm just going to jot that in right here, negative square root of 3 over 3. The tangent of 7 pi over 4, which is 315 degrees, that should give me a negative 1 for the tangent. And then for 5 pi over 3, which is 300 degrees, the tangent for 300 degrees is negative square root of 3. So that should help me better to find this arctangent value. So let's just go back for a second. So it says what angle in the interval from negative pi over 2 to pi over 2 has a tangent value of negative square root of 3? So if I look back at my intervals, and if I look on the right-hand side of my unit circle, the angle that has a tangent value for negative square root of 3 should be negative pi over 3 radians. So my solution here is negative pi over 3 radians. All right, so any questions about finding inverse of sine, cosine, or tangent? Now, in the next set of problems, they ask you to find, let's say, the cosecant and, well, the arc cosecant and the arc secant, as well as like the arc cotangent, but they ask you to use a calculator. So since we're using the calculator, here are some formulas. The arc cosecant of x, that's equal to the arc sine of 1 divided by x. And I'll show how these work in just a second. The arc secant of x, that's equal to the arc cosine of 1 over x. And the arc cotangent of x, that equals to the arc tangent of 1 over x. All right. So we're simply going to use these formulas in the calculator to evaluate. All right, so here are the formulas. All right, so this is similar to your problem number 5. Here again, it says use a calculator. So we're using a calculator. And we're asked to express the answer in radians. So once I turn my calculator on, I'm going to go into mode. I'm just going to make sure that I am in radian mode. And it says round to the nearest hundreds, or the nearest 2 decimal places. So here we're asked to evaluate the arc cosine of negative 0.8. Now I do have an arc cosine function on my calculator, so it's second in cosine. I'm going to put in negative 0.8. And if we round to the nearest hundreds, I believe we get 2.5. So that would be 2.5 radians. All right, now problem number 6. I don't have an arc cosecant function on my calculator, but here is the formula. It says that the arc cosecant of x, that's equal to the arc sine of 1 over x. So that just simply means in this formula, I'm going to replace x with 7. So that means that the cosecant of the arc cosecant of 7, that should equal to the arc sine of 1 over 7. We have to reciprocate the argument for the inverse of cosecant. So now I can put this in my calculator. I can put in the arc sine of 1 divided by 7. And here they want us around the 4 decimal places, so that looks like 0.1433. 0.1433. All right, for problem number 7, we're asked to find the arc secant of negative 3. So here's a formula for the arc secant. The arc secant of x, that equals to the arc cosine of 1 over x. So in this formula, I'm just simply going to substitute x for negative 3. So that means that the arc secant of negative 3, that equals to the arc cosine of negative 1/3. So I'm just simply taking a reciprocal. I'm not changing the sign or anything. Negative 3 over 1, when I reciprocate, that becomes negative 1/3. So I do have an arc cosine function in my calculator, so this becomes the arc cosine of negative 1 divided by 3. And if we round to 4 decimal places, we have 1.9106. So the arc secant of negative 3 is 1.9106. Okay. And for the last one, the arc cotangent of negative 4/3. Okay. So here's that formula. The arc cotangent of x is equal to the arc tangent of 1 over x. So that means that the arc cotangent of negative 4.3 is equal to the arc tangent of negative 1 divided by 4.3. So this is the arc tangent of -1 divided by 4.3. Round it to 4 decimal places, -0.2285. All right, any questions about those problems? Now these things say specifically use a calculator. All right, and then the last two problems in this set, they deal with evaluating some trig functions. So now even though this thing may like look confusing, it says find the exact value in radians. So notice that my outermost function is an arc cosine. So the answer to this is some kind of angle measure. And if I look at this one, the same sort of thing, it's an arc tangent, which represents an angle measure. All right, so now how we go about solving it is no matter what math class you're in, you're always using order operations. Please excuse my dear Aunt Sally. And in that order operations, the P stands for you have to simplify what's in the innermost parentheses. So that's what I'm going to do. I'm going to just bring down this arc cosine or inverse cosine. And I'm going to evaluate the cosine of 3 pi over 4. So I can find the value for 3 pi over 4, I guess a couple of ways. I could use a unit circle, or I could use the function, the unit circle function of values chart. Right. So we could find 3 pi over 4, which is 135 degrees. Its cosine is negative square root of 2 over 2. So that means that the cosine of negative 3 pi over 4 is negative square root of 2 over 2. So let me just put some steps on this. So the first thing we did was simplify the innermost parentheses. So we've simplified the innermost parentheses. The cosine of 3 pi over 4 is negative square root of 2 over 2. Now, how can we find the, and let me just write this out the right way. How can we find the arc cosine of square root of 2 over 2? Well, we can interpret it, right? What angle in the interval from 0 to pi, right? Keep in mind that the arc cosine runs in the interval from 0 to pi, which is the top part. Okay. Has a cosine, which is an x value of negative square root of 2 over 2. Well, if we look at the unit circle, okay, in the interval from 0 to pi, we want to find the angle that has an x value of negative square root of 2 over 2. So if I'm looking in quadrant 1, I'm looking at my x values, that's a positive. If I look at quadrant 2, the angle that has an x value of negative square root of 2 over 2 should be 3 pi over 4. So the solution here should be 3 pi over 4. So you simplify the innermost parentheses first, and then you simplify the outermost function. All right, and then number 11 is the same way. We have the arc tangent for the tangent of 2 pi over 3. So first, let's simplify the innermost parentheses. So what is the tangent of 2 pi over 3? Well, I'm going to use the unit circle function of values chart. 2 pi over 3 is 120 degrees. The tangent of 2 pi over 3 is negative square root of 3. So we've simplified the innermost parentheses. And now the last thing we're going to do is interpret. So this is what angle in the interval negative pi over 2 to pi over 2 has a tangent value. And the tangent is y over x of negative square root of 3. So if we use a unit circle, we look on the right-hand side of the unit circle. And notice we jotted those tangent values in earlier. So the angle that has a tangent of negative square root of 3 looks like it's negative pi over 3. So in this case, theta is negative pi over 3. All right, so any questions about number 11? All right, now I'll just kind of introduce the next section. In 3.1, I'm going to bring up XYZ homework. Okay, it might help if I take the caps lock off. All right, so in the next section, or the next module, excuse me, module 3. All right, so there will be a module 3 test. It's just not a module 2 test. And for module 3, just to look ahead, we will be, I'm going to pull up this all exam formula sheet under formula sheets. And in module 3, we basically cover the first part of this formula sheet. The only thing we don't cover is this law of sines and law of cosines. There are a set of formulas that are not on this formula sheet, and they are called the negative number identities. And they're like the first things that you encounter in this 3.1 homework. So these are actually called the negative number identities. And let's see where you could find those in the lecture notes section. This stuff is all scattered out. Okay, it's actually in section 9.1, just to show I'm getting this stuff from. And in section 9.1, this set of notes, it is on this very first slide, and it is called negative number identities. And I just want to show how this works. If you think about back to algebra, normally when you talked about exponents, it says make sure that all exponents are positive. So you had to like flip-flop some stuff using a negative exponent rule to rewrite a negative exponent as positive. The same thing is sort of true in trig. When you write out an angle measure, the angle measure should be written out as a positive angle measure. So we kind of keep that concept in the back of the head. So these negative number identities, the first one says that the sine of negative theta, that's equal to negative times the sine of positive theta. So this is the negative number identities. The sine of negative theta, right? So this trig function has a negative angle measure, which we try to avoid. You can write that as a positive angle measure by using this formula. So it says that the sine of negative theta, that's equal to negative times the sine of positive theta. So notice it's like the negative angle is now written as a positive angle. But I want to show you with the calculator that these two statements are exactly the same. That's why they're called identities. For example, the sine of negative 30 degrees. So I'm going to go back to my calculator and I'm going to make sure that I'm in degree mode. So I'm just going to change that to degree mode. The sine of negative 30 degrees is equal to negative 0.5. That should be equal to negative times the sine of positive 30 degrees. So if I put negative times the sine of positive 30 degrees, I get the same number value. The only difference is I'm able to express a negative angle as a positive angle. The next negative number identity says the cosine of negative theta, that's equal to the cosine of positive theta. So if I kind of go back to the formula sheet, right, the cosine of negative theta is equal to the cosine of positive theta. So it's like when you're dealing with the cosine, it's like you could just sort of make a negative angle a positive angle. But just to show this on the calculator, the cosine of negative 30 degrees, if I put that into my calculator, I'm going to get the cosine of negative 30 degrees is 0.866. That's the same thing as the cosine of positive 30 degrees. So if I were to put in the cosine of positive 30 degrees, notice I get the same exact number value. And you're going to see that done from time. You're going to see that done from time to time. They're just simply in one step, especially if you're dealing with a cosine, the angle's going to be negative, and then in the next step, without them saying anything to you, they may just change the sign. And they're using this negative number identity to do that. And then the third negative number identity says that the tangent of negative theta, that's equal to the tangent, that's equal to negative times the tangent of positive theta. So if we use an example with this one, the tangent of negative 30 degrees, that should equal to negative times the tangent of positive 30 degrees. So notice we're making negative angles, positive angles, okay, with some adjustments though. So just to look at this fact on the calculator, the tangent of negative 30 degrees is negative 0.577. Negative times the tangent of positive 30 degrees has that same value. And then there are some problems that kind of use these facts. Now, the very first problem in module 3.1, it just wants you to evaluate this. It wants you to, you can rewrite okay, just to show how this first one is done, let me copy it. All right, so this just says evaluate. So what this means is I can use a negative number identity to rewrite the sign of negative 5 pi over 4. I can write that as negative times the sine of positive 5 pi over 4, okay, times the cosine of pi over 2. The reason why I want to make sure that my 5 pi over 4, this angle is negative, is because when I use this function, unit circle function of values, okay, all of my angles are positive. So if I were to find 5 pi over 4, which is 225 degrees, the sine of 5 pi over 4 is negative square root of 2 over 2. So I have to bring this negative down. The sine of 5 pi over 4 is negative square root of 2 over 2 times the cosine of pi over 2. All right, so if I look in the unit circle, the cosine of pi over 2 is 0. So a negative times a negative is a positive. So this is square root of 2 over 2 times 0, which is 0. All right. So we use the negative number identity to rewrite the sign of a negative angle as negative times the sine of a positive angle. All right. And then we'll just take a look at a couple more. Like for problem number 2. Let's see if I can get all of this screen. All right, so for problem number 2, this says what is, if sine of t is equal to negative 0.4, what is sine of negative t? So they're giving us the sine of t is equal to negative 0.4. What is the sine of negative t? So since they're asking for the sine of negative t, I'm just going to write that formula down. It says that the sine of negative t, that's equal to negative times the sine of positive t, right? So that comes from this, right? The sine of negative theta or negative t, that's equal to negative times the sine of positive theta or positive t. Right, so I just simply use that formula and just substitute theta for t. The sine of t is equal to what? Negative 0.4, right? They gave that to us in the problem. So in this formula, I'm just going to substitute the sine of t for negative 0.4. Right? So I'm going to bring down the negative, which is a part of my formula. I'm going to substitute the sine of t for negative 0.4. And then a negative times a negative is a what? Positive. So the sine of negative t should equal to 0.4. All right, so the sine of t, it should be 0.4, positive 0.4. All right. Number 3 says if the tangent of x is equal to negative 4.5, what's the tangent of negative x? So I'm going to just bring this over so I can write on it. And we're going to basically do the same thing, right? They want us to find the tangent of negative x. So I'm just going to write out that formula. The tangent of negative x, that's equal to negative times the tangent of positive x. And they give us that the tangent of x is negative 4.5. So I'm simply going to substitute tangent of x for negative 4.5. So I'm going to bring down my negative. The tangent of x is negative 4.5. A negative times a negative is a positive. So the tangent of negative x should be 4.5. Positive 4.5. All right, so if we take a look at this one, you should have positive 4.5. And then let's take a look at, I guess we'll do all of these. Okay. So 4 says the cosecant of x is equal to 3.5. Find cosecant of negative x. So now, even though I didn't write all 3, the cotangent of negative x, that's equal to the negative cotangent of x. So notice the tangent and the cotangent are similar. The sine of negative x is equal to the negative sine of x. Its reciprocal is similar, right? The cosecant of negative x is equal to the negative times the cosecant of x. And then if we look at cosine and secant, right? The cosine of negative x is equal to the cosine of x. And the secant of negative x is equal to the secant of x. So even though I didn't specifically write down these 3 rules, right, the reciprocals apply. So let's take a look at number 4. All right, so I'm going to write down the formula for the cosecant of negative x. So the cosecant of negative x, that's equal to negative times the cosecant of x. And they give us that the cosecant of x is 3.5. So I'm going to bring down my negative. I'm going to substitute in the cosecant of x for 3.5. And the cosecant of negative x is negative 3.5. And then we'll do the last one, the very last problem. Secant. All right, so we're going to do the same thing. If the secant of x is equal to negative 7.5, find the secant of negative x. So the secant of negative x, that's equal to the secant of x and they give us that the secant of x is equal to negative 7.5. So I'm simply going to substitute secant x for negative 7.5. And that should equal to the secant of negative x. It should be negative 7.5. Right. So we take a look at that last one. You should have negative 7.5. All right, so any questions about the first couple of problems in 3.1? All right, now when we meet again, we'll kind of go through the rest of the sections. Here again, Module 3, it deals with the formula sheet. All right, so we're basically going to go down this first page of formula sheet. We're also going to see sine squared, cosine squared equal to 1. We're going to see how this builds up from c squared is equal to a squared plus b squared.